Hello everyone, I'm Kudo at Suga Company Limited. Suga Company Limited is a vacuum equipment manufacturer headquartered in Hokkaido, Japan. I joined the company in 2011 and spent 10 years in the engineering development division, working on deposition systems such as sputtering, ALD, and evaporation systems. In 2021, I moved to the sales division, and I am currently in charge of sales. Today, I would like to explain the basic mechanism of sputtering deposition using the SSP1000 cubic sputtering system, a compact sputtering system that I personally helped develop. Sputtering was first observed in the 1850s and has been used in industrial products since the 1960s. There are many papers and textbooks about sputtering, so I recommend learning the theory from those materials. However, in this video, I will explain the mechanism without using difficult formulas, so that you can visualize the process in your head. Please watch until the end. First, let me explain the system configuration using this block diagram. The system consists of a vacuum chamber, a turbomolecular pump, and a rotary pump, which together create a vacuum environment. Argon gas is supplied through gas line, and the substrate is placed on a rotating stage. The film is deposited while the substrate is rotating. The target material is placed on an electrode called the cathode, which contains a water-cooled magnet inside. An RF power supply provides up to 300 watts of 13.56 MHz power, and a matching box performs impedance matching to supply power to efficiently. Next, let's take a closer look at argon atoms, which play a very important role in sputtering. Argon has an atomic number of 18. Its outermost shell contains 8 electrons, which makes argon chemically very stable. This is called a noble gas, while there are other noble gases like helium and neon. Argon is commonly used because it is contained in the atmosphere and is easy to obtain. Please remember that electrons are very light while protons are very heavy. If an electron weighed 1 kilogram, a proton would weigh about 1,840 kilograms. Now, let me explain the sputtering process. First, we evacuate the chamber from atmospheric pressure down to about 10 to the minus 3 to 10 to the minus 4 pascals. Next, we turned on the RF power at about 13 watts. At this stage, no discharge has started yet. When argon gas is introduced, the RF voltage applies force that tries to pull the electrons and protons of the argon atoms apart. However, RF voltage alone is not enough to maintain a plasma state. This is where the magnet inside the cathode became important. Based on Fleming's left-hand rule, the magnetic field forces electrons into a circular motion. This increases the travel distance of electrons, leading to more collision and ionization. This chain reaction maintains the plasma state, the fourth state of matter after solid, liquid, and gas. On a magnetron sputtering system, you can actually see a donut-shaped plasma right on the target surface where the magnetic field horizontal. The cathode develops a negative DC potential called VDC, which attracts the heavy argon ions towards the target. When these heavy ions strike the target, atoms are ejected, travel to the substrate, and accumulate to form a thin film. Once you understand this mechanism, you can predict what happens with different materials. For example, if you use a magnetic material like iron or nickel, the magnetic field lines stay inside target. To fix this, we can make the target thinner so the field leaks out. Or use stronger magnets like samarium cobalt or neodymium. In summary, let's review the three main steps. First, the chamber is evacuated to a high vacuum and argon gas is introduced. Then, by using electromagnetic force, a discharge is continuously generated. This is the plasma state. Second, the argon positive ions created by ionization are attracted by the negative VDC voltage of the cathode. They collide with the target material at high speed. Third, the atoms ejected from the target travel through the vacuum and accumulate on the substrate to form a thin film. Thank you very much for watching until the end. We will continue to share videos useful for your experiments. So please subscribe and hit the like button.